Hello, this is Alexei from Neu.ro, and today I'm going to show you how you can use our platform to run hyperparameter tuning jobs using NNI. NNI is an open source ML toolkit from Microsoft which simplifies multiple ML related tasks, and we're going to use it today for hyperparameter search, as I said. My initial setup was to install Neu.ro CLI and log in, so I can show you that I am just logged in, and I'll start with running Neu.ro project init command, which creates a boilerplate folder structure and some configuration files that simplify running jobs on Neu.ro platform. I'm going to call my project NNI example and use defaults for project slug and code directory. Now I cd to the NNI example directory and open PyChart. So as I said, this is just a boilerplate which doesn't do anything. And we'll start with copying over NNI integration example code from the repository. I go to the examples trials mnis TensorFlow version 2 example, and I need just two files. One is mnis.py, which is the code of the trial, and I simply copy the file without any changes to the modules folder. And the second file that I need is searchspace.json, which contains configuration for our hyperparameters. And I put this file to the config folder of my project. Again, no changes required. Then I need to add some configuration and scripts that allow us to use NNI and multiple worker nodes with our project and with our platform. I navigate to the ML recipe NNI repository on the Neu.ro organization, and I start with adding some Python requirements. Just these three lines: Jinja2, async.io DNS, and NNI. I put them to the requirements.txt of my project. So Jinja and async.io DNS are used by the script that generates NNI configuration, and that's just the NNI library itself. Then I copy over nni.mk. That's a make file with the commands that run NNI jobs. So again, no changes required, just copy it over here. And before I forgot, I go to the make file and include nni.mk at the very end of the file. Last two steps are copying two configuration related files. One is nni config template.yaml. This file contains Jinja2 template that we expand to a full NNI config with multiple worker nodes. I copy this file to the config folder and prepare NNI config.py, which is a script that leverages Neu.ro platform API to generate the configuration file. We are done with the files. Now let's switch back to the terminal and run make setup. This make target creates folders on platform storage for my modules, data configuration, results, and so on. And it also builds a custom Docker image that contains all the dependencies and the files that we're going to use. It takes about 2 minutes, so let's wait for it to complete and then move on. Okay, we are done. Our image has been built and pushed to the Neu.ro platform registry, and we can finally run make hyper train. This make target runs 3 worker nodes, and once they are up, it also runs the master node that controls the experiment and generates configuration file at the master node that points at the workers. And finally, it opens up your browser with the NNI web UI so you can track the experiment in real time. Again, it takes a while to run these nodes, So let's wait. So now we've got 3 worker nodes running, and we are starting the master node, which will control the experiment. And now, as you can see, the web browser opened up automatically for us, and we've got the NNI experiment running. We can see that we've got 3 trials running. This is the configuration that we use. And here we'll get the results. In the meanwhile, let's go to the trials detail page. See there are 3 jobs running by the number of worker nodes we've got. And the page refreshes automatically with the latest information. So let's just give it some time to get the results. So our last experiment is done, and we can look at the final results with Hyperparameter Search, check the duration, get intermediate results, and take a look at the dashboard. So now we've got the results. We're done with our experiment. We know hyperparameter values that we're interested in. And the very final step that we do is we go back to the terminal and call make kill hypertrain. And what this command does, it shuts down the worker nodes and the master node in order to save your platform usage quota. So we run this, and it finds all the jobs and kills them. So basically that was it. The whole process took us just a few files to copy and paste, very minor changes to the make file and to requirements.txt, to make commands, make setup and make hypertrain, and we've seen the whole process in real time. Finally, you can find the documentation on our website docs.neu.ro. Where you can get the same information but in the text form. Thanks for watching this, and I hope you'll find everything you need on the Neu.ro platform.